All right. Hello, everyone, and welcome to another episode of AI in software development. Today, we are going to talk about an interesting topic, the AI agent-driven quality engineering. So I have with me Saurabh today. Saurabh, do you mind introducing yourself to our audience?
Hi everyone, my name is Saurabh, and as Mayank introduced me, I am a quality engineer, and we have been exploring the AI part in quality engineering for a bit now. But recently, since last few months, we got into agentic AI, and using that, we have explored multiple scenarios, a couple of which we'll be mentioning today. Hope you find it exciting enough for you to explore the same.
All right. Super pumped for you to be here, Saurabh. For our audience, I am Mike. I play the role of a delivery lead at Devon. I'm responsible for end-to-end software development and delivery. So, Saurabh, what are we going to talk about today?
We are looking into agentic AI, which explores specific tasks that you want for this agent to do for you. So what we have seen earlier, like if you were talking about regular tools that we have been using, which are doing things, when you make an LLM call, you make twice, thrice, four times, you get a different result every time. So if you are able to build a specific agent to do that specific task for you, then what you get out of it is borderline magical, I would say.
Let me scale it down. I think we hopped a few steps here. Let's start at the beginning. These days, Saurabh, in our experience, almost everybody is using different tools like GitHub Copilot, ChatGPT, Claude. They've all become part of the developer toolkit, right? So why did you feel the need of building your own AI agent? What was missing, which was not already available with these tools?
Yeah, Mank, as I said, it's been around 2 years or more than that since we have been using Copilot, Amazon Q, or Claude, or most importantly, the most commonly used tool is ChatGPT. Having these assistants is like having a really smart intern who have read
Okay.
all your docs but haven't actually seen how your particular team works. So what we are doing here is simple as well as a complex thing. What we are getting out of it, very simple, but what we have built inside is your own locally existing AI itself. So
Okay.
we have already explored couple of scenarios there. What we have done is we have created an agent that converts your regular HTML forms into React pages. There was a competition within Devon that we went through, and multiple teams participated in that, and multiple use cases were explored. One of them was which I just told you, and another one which we have recently been able to do is migrating from Cypress to Playwright in one go. So it's not a simple thing to do. Uh, it requires a very nuanced setup. There are helpers, there are selectors, there are test flows, and there are your DC DSL rules. So to achieve all that in one go, we have created these specific agents. At some point, what you realize is that if you're constantly prompting LLM, it's not sustainable. So what we
Right.
thought, let's build AI agents that understand our ecosystem and do this work on their own smartly and consistently.
All right. So you're actually talking about an agent system. What does this system actually look like?
So you need to visualize, let's say there's a relay race. In relay race, there are four runners. So
Okay.
one person runs, he has a
Hmm.
baton and he passes it
Right.
to another runner. He
Okay.
takes it, passes to third one. Like that, there are four agents we have. All these
Okay.
four agents we have orchestrated using DSPy. DSPy is a pipeline engine developed by Stanford. So
Okay.
if you're able to visualize that this flow, and for example, as I have already mentioned, we have created an AI application itself, which is able to convert Cypress into Playwright. So as I said, there are multiple agents. So let's say there is one agent which reads your Cypress text, maintains a context of it. Another one translates it into Playwright. Another one sets up the right config file and file structure. And a final agent does a dry run and a validation. So each agent has a clearly defined job, and DSPy orchestrates how they pass information to each other. It's modular, it's reusable, and super clean to maintain. So you don't have to rewrite everything for a new task, just swap out and tweak your agents.
All right. So in a way, DSPy is orchestrating the passing of baton between the four runners. Sounds
Yes.
pretty neat, Saurabh. So could you explain a bit more about how these agents actually collaborate? Because I can imagine a relay race, you know you have to pass on the baton to the next runner. But here you're talking about four different agents who are supposed to or required to work with each other, right?
Uh, so if you were able to visualize that four runners and passing on a baton, um, I want you to visualize one more thing. Uh, what if you are blindfolded and so is the other person? You don't know where you are going and where the other person is picking the baton from. What if there is a common table kept everywhere? So first person goes there, keeps it here. Second one collects it from here and then starts running. Okay, so this table, what we call is MCP. So around last year, we started using Claude, and for using Claude, I had to set up a small config file which we called MCP. But now you'd be hearing it everywhere. So
Okay,
MCP, if you the full form is Model Context Protocol. So using Model Context Protocol, it's like a shared notepad between different agents. It stores everything that's been done and discovered so far. So let's say, again, going back to the example that we are doing, Cypress to Playwright. Let's say first agent notices a cy.login command. Any application has login as the first thing. It logs that. Now the mapping agent that follows already knows that the command is there and it can handle it directly.
right.
So without MCP, it's like running a relay race with each runner who has no clues what the last one did. With MCP, they are synced and they are building on each other's work.
Okay, that sounds pretty neat. So in that sense, the agent which is required to pick up something already knows what the previous agent has done,
Yes.
and based on that, the agent can continue with the rest of the or one of the parts of the series of actions, for example. Right? So you mentioned MCP, which is Model Context Protocol, if
Model
I'm
context
not wrong.
protocol.
Right? The other thing that we hear a lot of time and that we use as well is RAG, RAG.
Yeah.
And I know that it's quite important in terms of giving context to the models. Did you end up using that as well in your architecture?
Yes, Mank. As I said, we have built this AI application within our local system. So to achieve that, we had implemented RAG, which is called Retrieval-Augmented Generation. So by adding that into the mix, what it's exactly able to do is provide more than the context to each of these agents that we have created. So LLMs are powerful, but they don't remember how you do things. They hallucinate or guess. Okay, let's say. You have done something and stored that. So next time, if so, we set a threshold value converting one A to B. If you are doing the same action again, you need not make an online LLM call. You just take data from the data that you have already stored, make use of that again. So what you're able to achieve online, you have set it up in your local. With RAG, instead of guessing, agents pull real references like your internal DSL rules or documentation or code examples. So if the agent is unsure how to usually handle drop downs or error message, it doesn't wing it. It searches for similar examples in our vector database and uses those to guide the answer. Basically, we are giving the agents the answer to the key from our own code base. It's like memorizing everything in advance, or it's like having a cheat book, but
Hmm.
legally.
Okay, okay. And where do you store this cheat boot, Saurabh? And I think you also mentioned something called embedding earlier.
Yes, Mayank. So, as I said, we are storing everything, right? If we have done something in advance, we store it in our local. You can call it caching, or to use the more refined word, we call it a database. Yeah, we are using vector database here, which makes use of embeddings. To implement vector database, you can make use of multiple databases. What we have used here is ChromaDB. So embeddings are how we turn words, code snippets, or even the whole test scenarios into numbers, specifically vectors that capture their meaning. We store with these vectors in ChromaDB, which is a vector database. When an agent needs help, like converting a test pattern, it sends a search query in a vector format, and Chroma returns the closest examples from our existing documentation. As I said, we have converted forms into HTML forms into React pages as well, right? So one time you are converting one text box, and another time you are converting another text box, but dimensions are different. As I said, it the closest example it picks, and we have set a threshold for that. If the dimensions match to the like 0.15%, it picks up the same. If it not, then it makes an online LLM call. Again, it's like having a
Okay.
really sharp memory that doesn't forget what your team did 3 months ago or 3 years ago. That's what make these agents context aware instead of generic.
All right. So you've spoken about the system that consists of agents, memory, knowledge retrieval. Um, since you've been using it, Saurabh, what has been the impact so far? What has worked well? I'm sure there will be multiple things considering it's all a new system. You're building it from scratch. I'm sure that you would also run into things which would not have worked well or which would come as a surprise. So do you have some examples around that?
So it has worked pretty well for us so far. What we are able to achieve out of it is not just efficiency. What we are also able to achieve out of it is implementing AI for free. What we implemented here is Grok. Grok is
Okay.
free to a good extent, but the more calls we are making, the more database we are building. The richer our database is, the less there is requirement of making LLM calls. So we are
Okay.
already at that stage that whatever we are converting from talking about uh, your HTML forms to React pages, we are not making any further LLM calls as of now because we have rich enough database. We have deployed this application into an Azure site, and we are directly able to make calls there. And we just make one LM call for validation. Otherwise, for conversion and for getting new components, we have good enough database. So on top of efficiency, we are able to achieve free information out of it. The problematic part, I would say, is implement coming up with this framework itself to begin with. And then on top of that, to make a good enough database, we had to convert multiple types of locators, multiple types of web elements. If you are just converting text box, then the next time if you have to convert a drop down, then you will have to make online calls. And the matching part itself will also take some time. Even in making text box, if you are making use of same AI application to convert a totally different page, then again you might run into some issues. So making these applications richer, more intelligent will take some time as
Okay.
with
Okay.
any AI.
Right. Right. And where do you go from here? Sort of where are you taking this framework next?
So these were the couple of examples that we had to begin with. We are already building a smart Scrum Master, which will anything that Scrum Master does. On top of that, what we have in Devon is our handbook. So sometimes we have to look through it. So we are creating a smart chatbot for that handbook as well. So it's the framework that's the most important part here. If you, like as mentioned before, if you tweak your agents as per your requirement and a bit of Python, the applications are endless. Whatever use case you can think of, the same framework can be implemented there.
All right. Sort of, this is one of the best conversations I had around AI, used in a very hands-on way, right? Before we wrap up, sort of, final takeaway. What would you advise somebody who is just getting started with all this?
Yeah, I'd say don't just use AI, build with it. You don't need to solve everything at once. Smart, small, use one case, you use one use case, one agent. You learn fast and the ROI is real. This thing came to us like around December last year. And we have already implemented two applications. We are in the process of building two more. So the best part, you'll go from copy pasting prompts to building systems that actually get smarter with every run.
All right, so it's clearly we are moving on to engineering over prompt engineering. Thanks again, Saurabh. And to everyone listening, please let us know if your organization is taking similar steps where you are venturing into agent engineering and what are you learning out of it. Thanks everyone for listening in. Thanks a lot, Saurabh, for sharing your valuable insights. And see you in the next episode of AI in Software Engineering.
Thank you, Mayank. Thank you, everyone.
Thank you.